So, as with all of these kind of engineering math problems, we want to think about how do we actually see this in the real world. And in this problem, we're going to take a look at time in decimal units. The reason for this, as we're going to see in the problem, is we're used to seeing time written like 12:56 p.m. or 3:12 p.m. 7:25 a.m. when classes used to start, But in industry, okay, when you're working for a business, they're often using computers to go ahead and keep track of how long you've worked. So in this case, we're going to say that you're working a full-time job, which requires 40 hours a week of work, and the software keeps track of it using decimal minutes. Okay? Actually, that's not accurate. Okay, that actually needs to say decimal hours. Okay. After returning from lunch on a Friday, the last day of the week that you're working, at 12:56, okay, you're signing back in, but you notice that you've logged 36.7 hours of work so far this week. At that time, okay, you want to know when you can actually call it a day and go off and enjoy the weekend. So what we need to do, okay, is we actually need to kind of convert. Well, we need to recognize that we're working 40 hours, okay, that 40 hours a week, and that we have some amount of time left. Okay. So we're subtracting the 36.7. We find the difference, and we should be able to kind of do it fast mental math. Should be about 3.3 hours left. Okay. You can always kind of validate that in the calculator. So 40 minus 36.7. Yep, 3.3 hours. Okay. But then we need to do the unit conversion to get it into both hours and minutes. Okay. So hours is pretty simple. We can just kind of chop off that 0.3, and then we can calculate what is that 0.3 hours going to be in minutes. Okay. And this is where we remember that 1 hour, well, 60 minutes basically is 1 hour. Okay, so we've got our unit conversion in here. Okay. Hour cancels out. 0.3 times 60 gives us 18 minutes. Okay. So we're working basically 3 hours and 18 minutes. We then have to add that. Okay. So that's assuming that you're not going to take any breaks or anything. So we're basically adding 12:46 p.m. plus 3 hours and 18 minutes that we need. Okay. So we just start piecing it together. Now, rather than starting with hours, we of course want to start with the smaller units, in this case minutes. So 46 plus 18 gets us 64. But we know that because 1 hour is 60 minutes, okay, that's adding another hour to kind of what we need to calculate. Okay. So we're now adding 4 hours, okay, to that time. Okay. So, knowing that we're starting, so 12 hours, basically noon, plus the 4 hours, means that we can pretty much call it a day at 4:04 p.m. Okay, a little after 4 o'clock. Okay. Again, time is something that we should be used to on a regular basis. But as I've had a couple of students who kind of work for a company like this that actually have to keep track of your hours, it's a very convenient way, and you can kind of only do the, always start at like some minute of 10, ends in a 0. But for pilots, for industry, decimal hours is actually a very common way of kind of logging information. Okay, I use it for my flight times. Businesses use it for how long the employees have been working. It's really boiling down to that 0.1 an hour is equal to 6 minutes. Okay, they like kind of grouping it in 6 minutes, then maybe to the quarter hour, so 15 minutes, 30 minutes, 45. So not the most fun calculations to do, but it is one that is commonly used in the real world. So think about it. Think about how you use it. The unit conversions and how you actually change and adjust time. Okay, I know this is maybe not the easiest way of kind of approaching it, but it is something to kind of think about for when you've got a job. So, as always, leave questions, leave comments, and as always, I'm here to help you out where I can. So, best of luck